Hey Algebra 1 students, today we are going to just do a little lesson on using the TI-84 to view lines. You know, we're just introducing Unit 2. We've gotten 2 lessons done so far. This would be the 3rd lesson, just a little warm-up here. And I want you to have your TI close by here. You see I have mine here turned on, ready to go. And we're just going to kind of go through these questions. So it tells us to use our TI-84 to graph these 4 lines below. So I'm starting with y equals 2x plus 5. So let's go to y equals, and we're going to type in 2x plus 5, and I'll hit enter to store that. The second one, y equals 2x plus 1, store it. Third one, y equals 2x minus 1. And the fourth one, y equals 2x minus 3. Now, it's funny, if you remember, if you have a good memory, and if you were either in class or watched my first video in this unit, we actually really dived into the relationship in this equation, y equals 2x plus 4. If you remember, we talked about the effect of the 4 on the line. We also talked about the effect of this 2 on the line as the rate of change. So I'm kind of going to be coming back to this in a second through these equations. So what I want to do is look at, before I hit graph here, I want to actually look at my window. So if you'll type window with me here. My window is a little crazy from calculus class, so we're going to switch it back to more of an Algebra 1 window. And so let's make the x minimum -6 and the x maximum +6, and we'll increment by 1s, and we'll do the same with the y's. We'll go from -6 to +6 by 1s. If you're wondering why I chose 6, it's because if I look at this back number here on all my lines, the biggest number I see is 5. So I wanted to go every direction at least 5 units, but I rarely like to go just to this number. I like to go a little bit further. So I figured I'd just do one more than 5, which is 6. So that's the reason I chose that. Okay, now we're going to hit graph and watch these lines appear in the order we typed them in. There's 2x plus 5, 2x plus 1, 2x minus 1, and 2x minus 3. So if you need to, you can pause the video and just kind of examine these and try to see, like, what is it about this equation? What is it about these relationships that hook up to these lines? Okay, whether you paused it or not, hopefully you had some time to think about that. And the first question here says that we're to predict the location of the line y equals 2x plus 4. So you have to think about that. Where would this line fall in with these lines? And then they want to know, why are you predicting this location? So if you look at what's similar about all of these lines is this 2x part. They all have the 2x. They all have the same rate of change. So for every line, I'm just going to write this up here, the rate of change for all the lines equals 2. There's a 2 in front of all of this. This means we rise 2 units on the y-axis for every 1 unit we run on the x-axis. Okay, so our rate of change for all the lines is 2, and it means that we rise 2 units on the y for every 1 unit we run on the x. Okay, so what's different about the lines is this back number. Now, if you remember, in our first lesson, we talked about the 4 being the location where the line crosses the y-axis or the y-intercept. So if you look at these lines here, if you look closely, get that under the light there, the first line, does it cross the y-axis at +5? Let's see, 1, 2, 3, 4, 5. It does. Does the second line cross the y-axis at +1? Yep, right there. Does the third line cross at -1? Yep, right there. And -3, 1, 2, 3, yep, right there. And they all have the same rate of change, which is why they're all parallel. For every, I'll just use this line to demo, for every 2 up, or I'm sorry, I rise 2 on the y for every 1 on the x, 2 on the y for every 1 on the x. And that happens for all of the lines, which creates this parallel feature. Okay, so I'm going to predict that the location of this line, 2x plus 4, is going to fall right here. So if I go up 4, 1, 2, 3, 4, my y-intercept will be here. So if I were drawing it, I think it's going to fall right in between the 2x plus 5 and the 2x plus 1. So that's what I'm going to write. So I'm going to say y equals 2x plus 4 is between y equals 2x plus 5 and y equals 2x plus 1. And why am I predicting that location? It's all about the y-intercept. So I'm going to say because, now look, I'm out of room, so let me just come down here to finish this one. Because 4 lies between a 1 and a 5, which are the intercepts on these two lines. So this 4 is between these two, so that's why it's going to be between. Okay, and then the last question says, how will the graph of y equals 5x plus 1 be different from all of these graphs above, and why? So think about that. You can pause the video to think about it. How is 5x plus 1 going to be different from 2x plus anything? So hopefully you're thinking it's got a faster rate of change. So let's put a rate of change of 5, which is this, is much faster than a rate of change of 2. You know, think of it as units per units. If you're, think of money. If something costs $5 for, what are we buying? What are we buying? What can we buy for $5? I'm asking my class. Gum, a pack of gum. Ooh, that's expensive gum, but that's all right. $5 for 1 pack of gum. That's way more expensive than $2 for 1 pack of gum. So this rate of change is much steeper, much faster, much bigger than this rate of change. I mean, you buy 2 packs of gum, it's going to cost you $10. You buy 2 packs of gum here, it's only going to cost you $4. So my prediction of how this is going to be different, I think y equals 5x plus 1 will be way steeper. It's great grammar there. Way steeper than, say, y equals 2x plus 4, because the rate of change is much faster. So we can prove that. So let's go back to y equals. Let me take out all these. And I'm just going to type in 2x plus 4 versus 5x plus 1. Okay, take a look at it. There's 2x plus 4. There's 5x plus 1. And you can see the steepness of the line. This one's not as steep as this one. So my prediction is correct. Okay, so that's just a little mini lesson, just checking lines out on your TI-84. Thanks for watching.